We kind of got sidetracked a little bit because of the Siemens Gamesa 5X blade breaking down in Brazil.
Yeah, but that's interesting. Everyone wants to hear about that.
I do, because I have a real bone to pick about the way that blade was tested. And I just need to understand from Rosemary in this episode, you hear me question her, like, what is going on? Why did they not catch it in testing? And Joel's being very sly because I feel like he knows more than he's telling us. But between Rosemary and I, we actually have a bet. And I'm going to end up sending her $20. I know that I am to Australia. But I think it's a good bet. I think we need to hash out what's happening. Right, Rosemary? I think we need to figure out what's happening with Siemens Gamesa.
Yeah. So we speculate a lot about what's going on. We're kind of piecing it together, Nancy Drew's story, Nancy Drew style, from the little reports that we're hearing. And I think, we got a lot more information in the latest one that we talk about in today's episode.
Yeah, and we also talk about renewable technicians being in huge demand in the United States, particularly in construction. And then the SeaTwirl vertical axis wind turbine that looks like they have another project up in Europe. So it's pretty exciting. I'm Alan Hall, president of WeatherGuard Lightning Tech, and I'm here with Vice President of North American Sales for Wind Power Lab, Joel Saxum, and international renewables expert, Rosemary Barnes. And this is the Uptime Wind Energy Podcast. SeaTwirl and Contiki Winds have signed an MOU to explore opportunities for electrifying offshore assets using SeaTwirl's floating wind turbines. So this sounds interesting because we haven't heard a lot out of SeaTwirl lately. So SeaTwirl makes these vertical axis wind turbines, but SeaTwirl has received a purchase order, which is the first step to making money, and that's where they need to get, right? To develop, they're going to develop a smaller wind turbine. They call it an S1.5 to withstand all of the torture of the North Sea. It's SeaTwirl's first commercial revenues, and it's a milestone for the company. So that's fantastic. Now, Rosemary, this is a little bit different. So what's happening here is the Contiki Wind is going to combine SeaTwirl's vertical axis floating wind platform with an existing farm. So it's basically going to plug in a turbine into an existing farm, not create a farm for the SeaTwirls. So it sounds like it's sort of a one-off, but it's on a trial basis, but they're getting paid to go make this turbine. That's a really good first step, right? To actually get a part in service.
Yeah, I think it is a logical next step. I've been following SeaTwirl a bit. Part of the consulting work I do is involved with innovative wind technologies, and so I follow what's going on in some of these new wind companies for some of my clients. And so maybe I can just talk through a little bit about what their history has been, because SeaTwirl, and this is their first. It's not really a sale because it's the purchase order for development, but it makes it sound like they're brand new, but they're not. They tested their first prototype in 2007. And then that was by their inventor tested that. So SeaTwirl was founded a few years later in 2012. 2015, they installed their first, SeaTwirl's first prototype, what they were calling an S1, which is a 30 kilowatt prototype. And that was installed in the sea outside of Lysekil in Sweden. So that's been going now for 8 years, and they have got videos on their website, and they do every now and then, stop in to check in on progress and how it's going. So I haven't looked in the last maybe nearly a year now, so I'm not exactly sure it's still in there, but it's got quite some operating hours on it. And then they began manufacturing for their S2, the second version, 1 megawatt unit in 2020. And they're still saying that they're planning to install that this year, but the last update that they had on their S2, other than this proposed, I think that this development funds is supposed to be for the S2. Their last update was in November last year, where they had placed an order for some bearings. So I expect that it'll probably be pushed through to next year or later. So yeah, I think it definitely makes sense now to put in, a single turbine in an existing wind farm. They don't have to reinvent every wheel in an offshore wind farm. I have sort of been a bit critical of their development process, that they've just immediately gone offshore. I think if I was the owner of SeaTwirl, then I probably, because they've got a vertical axis wind turbine and floating, um, and it's very different from existing offshore wind turbines. And if it was me, I would want to be testing out as much of that onshore as I could, because the offshore environment is it's harsh, but it's also really difficult to get out there. So like there's a lot of failures associated just with the fact that it's in an offshore environment, but there's also some things that would have failed onshore, like while they're figuring out exactly how the aerodynamics work. They've got, like I said, it's a vertical axis wind turbine, so it's not as well known, the aerodynamics about that. And the, kind of full scale operational behavior is not as well known as horizontal axis wind turbines. And so every time that they have to, replace a bearing that wasn't spec'd right, it turned out, or, repair a blade that suffered fatigue damage, or, I'm inventing these problems, but assuming that they would have had a lot of problems of that kind, it's really expensive to do that when you've got to get out and offshore. So, that would be the only thing that I would probably do differently. But it is good to see that they're piggybacking onto an existing project to hopefully, get this out and get real operational experience.
Yeah, I think this makes sense on the financing side, right? Go slow, get things working, figure out all your engineering problems, and then sort of move on. And in the US, on technician side, which seems to be a big area of growth, there is massive numbers of jobs in wind and solar at the moment. California and Texas are leading in clean energy deployment and also have the most wind and solar jobs. Solar and wind accounted for 87% of the new electric power generation jobs in 2022. All right. So solar is obviously much larger than wind in terms of total jobs, because if you've driven across the United States recently, like Joel has, there are solar panels going up everywhere. And there's 340,000 jobs in solar alone in 2022, Joel.
Well, I think part of why solar has the boom, and why, wind is as well, right? But a wind farm versus a solar farm, say 10 gigawatts to 10, or 10 megawatts to 10 megawatts, there's just less. That's not big, right? But there's less people that need to maintain that solar farm. However, when you're installing the solar farm, it takes piles of people. Because basically, installation of a solar farm is 5 phases, right? You're looking at the civil and pre-construction, all the dirt work that needs to be done. Then you have survey and layout goes with that one as well. And then there's pile driving. Then there's the mechanical installation. Then there's the electrical installation. And if you've ever driven past one of these sites when they're in the middle of that mechanical or pile driving installation, because most of it rolls on, right? You start, civil work starts, it's just about 50% done. Then the pile driving starts, they get through. And as they move through, then the mechanical guys start, then they move through, the electrical guys start. But you can have hundreds of people. There's trucks everywhere and little side-by-sides and skid steers and people running around like rats on these things. They're just all over the place. It's like organized chaos. Sometimes it's just chaos. But there's a lot of jobs in construction and solar. It's huge. And then once they're commissioned, they just don't take as much to maintain as a wind asset does, right? There's no rotating equipment. There's no blades. There's no, the mechanicals are pretty much in place. If there's an issue, you can dispatch someone to go troubleshoot it or something like that. So that's why there's a little bit of a disparity there in the jobs.
I think it's solar and wind, at least based on data here, we're seeing this is all the Department of Energy put out some stats. Construction makes up a significant portion of the renewable energy jobs, with about half of them of those construction, about half of solar jobs are in construction, about a third of the jobs in wind are around construction, which seems about right based on what I have seen. But yeah, it seems like maybe probably some of the better paying jobs appear to be in construction. Obviously, there's travel involved and some late nights and weekends on the construction side, but it's probably, probably going to make a little more money in construction at the moment because there's more demand.
One of the things I talk to a lot of wind energy companies, ISPs, and everybody we talk all the time about the shortage of workers. But now the problem's people are starting to dig into the problem a lot more in the field and trying to understand. At this point in time, the majority of the people are soaked up, the people that are knowledgeable, right? And if you are knowledgeable and you're not working in July in the U.S., maybe you need to take an internal look at yourself because there's something you're not doing right as a person because there's jobs everywhere, right? So the trouble now is that almost everybody new to the field is going to be 100% green, is going to need to be trained somehow. Because anybody that's got experience in this sector they're working.
So the big places, if you're going to be in wind and work wind construction, you're going to be where at this right now? Like what in 2023, where are the hot spots for wind construction?
The wind corridor in the U.S., of course, you're in Texas, you're up and through the Midwest, Iowa, Minnesota, South Dakota. Quite a bit actually in Illinois is what I've heard, but then you're getting some eastern Nebraska. Actually quite a bit of wind farms going up in Wyoming. In California, a lot of repowers going on, but I don't see a lot of brand new wind farms going on out there.
I think California is mostly solar, right? It seems like wind is sort of dying off there.
Solar's anywhere they can get in the queue and get a permit accepted, to be honest with you. There's a lot of solar on the East Coast, right? The Carolinas and Virginia and stuff, they're putting in solar everywhere over there because that's the renewable energy source there. You're not doing wind farms over there unless they're offshore because the wind resource onshore is nil.
So the outlook for wind jobs is really high. And just looking online, obviously the government in the United States goes and does surveys and tries to get a sense of it. I think the better way to feel the pulse of the wind industry is to look at the job posting boards, monster.com, LinkedIn. I saw a LinkedIn post today. People are looking for 10 technicians coming up in July. It's already July and you need 10 technicians. Yikes, it's a little late. But yeah, if you're competent, you should be able to find some work at the moment. Yeah, Indeed. Yeah, Indeed is another place. Yeah, those are good places to check. I know people reach out to me occasionally like, hey, where are the wind jobs? Like, go to the job boards. That's where all those jobs are posted.
Scroll through LinkedIn. Every ISP is hiring.
I think technicians miss out on a LinkedIn piece. I think the companies post on LinkedIn, but I'm not sure all the technicians are there. There are a significant portion of technicians on LinkedIn, but you see a lot of technicians still hanging around Facebook. And I don't think the job postings are there. Go to LinkedIn, right? Absolutely. Check out LinkedIn.
As we speak on this, I just put in where 0, no place, and put wind turbine technician into Indeed, and 839 jobs showed up. Your top ones, we'll give a little shout out here. Our top ones are Airway Services, which I think Vestas owns part of them. Sky Climber, GE Renewable Energy actually hiring traveling technicians, EDF, Vestas, Rangel Renewables, we know the team over there. AES, Siemens is hiring some traveling technicians, Duke for some large corrective people. So a lot of opportunities out there.
And the way that the lightning season has been this spring so far, there's a lot of blade repair jobs at the moment. So yeah, a lot of jobs. Keep your eyes open. Check out LinkedIn.
Ping Monitor is a continuous blade monitoring system which allows wind farm operators to stay ahead of maintenance. Wind techs can often hear damaged blades from the ground, but they can't continuously monitor all the turbines. They also can't calculate how bad the damage is or how fast it's propagating based on sound, but Ping can. Ping's acoustic system is being used on over 600 turbines worldwide. It allows operators to discover damage before it gets expensive and prioritize maintenance needs across their fleet, and it pays for itself the first time it identifies serious damage or saves you from doing an unnecessary visual inspection. Stop flying blind out there. Get Ping's ears on your turbines. Learn more at pingmonitor.co.
Well, it happened down in Brazil. A Siemens Gamesa 5X machine blade broke, and the lucky operator was NG. So down at the Santo Agostinho wind farm, blade snapped off. NG decided to shut down the farm, at least temporarily, to figure out what is happening. And now we've heard through the grapevine and in news reports that the blades for the 5X machines seem to have some sort of defect. I'm guessing that this is not the last time we're going to hear this, but it sounds like Siemens Gamesa has crews out trying to talk to customers, talk to blade companies, just trying to, one, understand, and two, reassure everybody they're going to try to take care of the problem. But Joel, have you heard much, or Rosemary, have you heard much of like what the exact issue is and what companies and operators are supposed to be looking for on these 5X blades?
I haven't heard anything, but Joel's grapevine is probably higher quality than mine.
I was going to defer to Rosemary because I don't want to be the one that says what I've heard. So I'll tell you this, Alan. We'll stay tuned in the next few weeks, and when I've got something definitive where I feel comfortable sharing, I'll share it. However, it is known in the industry, like in North America at least, that the 5X SG-145s have got some issues. Again, I don't want to be the one who says exactly what I believe they are until I can be 100% certain on you. But I would imagine that with this happening right now, there's some Siemens Gamesa engineers on a plane, hopefully heading to Brazil if they're not already there already, diving into this thing to better understand. I think they know what the issue is, but when you finally get a failure, it's nice to get your hands on it, understand exactly what the failure mode is, because the more details you can get forensically about the failure mode, the better you can engineer a retrofit to fix it.
But maybe we can do a little bit more speculating now based on this latest bit of information, because I guess I've been just, piecing it together, kind of drip by drip. The announcement from the CEO a few weeks ago that we spoke about a couple of episodes back was obviously alerted us beyond a shadow of a doubt that it wasn't just rumors that maybe there were issues that, definitely there are with this particular turbine. But now we see, so this wind farm that, was affected this time, it's 434 megawatts, so not small. Assuming that they're all the same turbine, it's not normal that you would, mix up types. So they've got, over 1,000 blades. It's not, I don't think it's commissioned yet, right? They're in the middle of installing it. From what I can gather, they've totally suspended work on that. So, I've worked on some pretty serious blade failures before, and they will stop the affected turbine for that. If it's super duper serious, they'll take the blade off the turbine for that. But this is not just that they are stopping a turbine from operating. They're not just stopping turbines from operating across the whole site. They're not even continuing to install. So we can learn a couple of things about it from that. First, that it is a significant defect because it's occurred before the turbine was even commissioned, probably, or if it was commissioned, that specific one, it was very, very early days. So it's likely not a fatigue issue. It's something big that it's hard to even imagine how that blade would have passed the, static tests, let alone the fatigue test, and then fail so quickly in the field. We know from what the CEO said that they think that this issue affects, was it 15 to 30% or something? So, a lot. I think that they've also suspended manufacturing of these blades in their factory in Brazil, at least. So perhaps they've isolated it down to that one factory, but sounds like they're going to expect that they're going to have to do a major redesign at a minimum. But what their strategy is to mitigate the blades that are already out there, they're not installing them on turbines. That's significant cost. If they've got workers and equipment that's sitting around doing nothing now, that's not for fun. That's because they think that wasted money is less than what they would have to spend to fix these blades up tower, or maybe it's so serious that they can't fix it up tower. So yeah, that's kind of where we're at. Maybe it's a benefit here that I haven't heard too much on the grapevine, because I know that I'm not saying anything that I shouldn't be, because I'm just piecing this all together from, public information saying that anybody can come by. But is it even possible that they could be looking at replacing all of those blades? It's so rare that you ever replace even one blade. I've, worked on some some defects where you had to maybe replace half a dozen or so would be a huge big deal. But could it be that they don't have a solution for this and may not get a repair solution? Happens occasionally. I've never seen it fleet-wide before, though.
I do know, like, I've seen it before where you can have a fleet-wide issue and have to go and do a massive repair or retrofit, basically, campaign, right? Whether that's up tower or down tower is kind of remains to be seen, but I've got to think, or I got to hope for Siemens' sake, that there's something that they can do to rectify this issue that is hopefully an up tower repair, is in what happens in my mind.
Yeah, but it seems to me like they're at least worried that they won't be able to find an up tower repair. And I mean, I've worked a bit with, like developing new repair methods and getting them certified. So it could just be that they have to come up with a new method and they're working through the process to get that tested and certified so that they can roll it out. Usually, like, there's not a lot that you couldn't repair in a blade. Some of the big things are, if there's issues around like protrusions or something like that, then that's difficult to fix. And a lot of stuff to do with carbon fiber. It's not possible to repair everything like that. But otherwise, it's a matter of, is this repair going to be so intensive that it would actually be cheaper to replace the blade? Because, when you're trying to repair bits of composite material, you can't just, like cut out the damaged part and plug in a new one. You have to, because the strength is transmitted through the lengths of the fibers. So when you cut it, then there's no way to transfer the loads from, one cut fiber to the next one. You need to do a really long chamfered joint so that it's a, gradual transition and you're getting some load transfer. And so you can imagine that when you have like a defect that you've got to cut out, then you need to chamfer around the edges. The size of the repair grows and grows and grows. And then you start, okay, so it gets bigger. And now you had to cut away, the bit that was over the web or something. So then you've got a new feature that you've got to figure out how you're going to transfer the load back down to the web like it was supposed to, and get the glue joint right and everything. And you can end up, if there's a lot of layers affected and it's in a bad location, you can end up with a repair growing and growing and growing until it might be, like 10 meters or more. And then you start to be basically trying to rebuild your whole blade in field, and it's not worth it. It must be something like that.
Yeah, let's do some armchair math on it, right? We know that right now, if I had to go for one turbine, I have to mobilize a crane and replace 3 blades. The cost of 3 new blades plus the crane can be upwards of 1.3, 1.5 million US dollars. So, and that's, you're going to mobilize a crane, you're going to do. So we'll say, just say $1 million per turbine. That's $333,000 that you get to basically fix the blades that are out there. So each blade, you'd have that much, $333,000. If you have it still up tower, that is, 6 months worth of a team on there at least. With a 360-degree platform. You can do a lot of work in that amount of time, but there's no way in hell there's that many technicians and horsepower available in the market to do that kind of retrofit campaign. It's just not going to happen. And cranes, it's just not going to happen.
They're lucky to, a certain sense, because they are still in construction. So they've still got the cranes there. The blade is still in production. So that's at least something. But I think that there's another piece of information we can gather from this new story as well, which is that the problem is worse than what they thought it was when we heard that announcement from the CEO a few weeks ago, because they were continuing to install more of this blade that they knew was affected, and they wouldn't have done that if they expected it to the blade to break up tower. That's obviously the effect of their failure is worse and faster than they were expecting it to be. So that $1 billion figure that they estimated before, I mean, we knew at the time that those figures don't get smaller, right? That, any serial defect campaign you've ever worked on, they just grow and grow and grow and grow. So I think we're starting to we're seeing the first part of growth now. That figure would have to be blown out of the water, and it was huge to start with.
There'll be some wild lawsuits that come from this because, so here again from the insurance side of things, insurance, there's 2 different policies. Well, there's multiple policies, right? But there's two big. There's a ton of policies, but there's two very large separations, and that is construction policy and operating policy. So you're going to have construction, and sometimes the construction policies won't have business interruption costs on them. But now you're starting to get into massive business interruption costs because technically some of them haven't started operation. Or maybe these are commissioned just like days ago, and so they technically have started, but you don't even have a backlog of what the business interruption cost would be. But business interruption costs in insurance are regularly 3-to-1 property damage, right? If you got $500,000 in property damage, a lot of times business interruption's 1.5. So the sorting this out in this big battle that's going to come, because this insurance companies aren't going to pay for it. They're not going to want to pay for it, right? They're going to sue Siemens Gamesa to say, you guys are the ones that are on the hook for this. And then the asset owners kind of caught in the middle. The queues that are stacked up are going to suffer. That it's not pretty.
I just don't understand, coming out of aerospace, like how this wasn't caught in the structural testing. What happens? It feels like on the lightning side, I feel like it's the same things happening on the lightning side. Like there's all these certifications and everybody's happy, and these wind turbines get out in the field and they get blown up. And now on the structural side, I don't understand how they have passed a structural test, and yet shortly thereafter they knew they had problems. I mean, how long have we been talking about the 5X problem? For like months, right? A year?
Yeah, I'm with you now. I wasn't last time we spoke because I assumed that it was a smaller, slower fault. But now that one has broken within, at most, a very short period of operation, that is really suggests that should have been picked up in the testing. Because I do think that the structural testing of wind turbine blades is far closer to reality than what the lightning testing of wind turbines is. There are still issues. You can't get when you test a wind turbine blade, you have to apply the load in fixed positions. So for the structural test, they attach some straps at certain points along the span of the blade, and then they pull it to bend it, right? So it's not exactly the same as when a gust of wind blows a blade and that's acting continuously over the whole blade. But in certain key points, especially at the blade root where the loads are the strongest, the stresses are the highest, that is a pretty good representation of what happens. And fatigue load, it is at the blade root. Yes, not everywhere along the span of the blade, but it's very rare that you would see a real structural problem towards the tip of the blade because the loading is so much less. Because it's like a big cantilever beam, right? When you load a beam, the where it's supported, that's the biggest load, and it should break either close to that where the stresses are highest, or it will break in a discontinuity of some type. So either where the material changes suddenly or the geometry changes suddenly, that's where you see stress concentrations, or a defect would also be a kind of discontinuity where you get a big stress concentration around there. And so you can, those would be the two places that you would see a failure. Fatigue testing is also fairly similar in that, they get a couple of exciters on the blade. I think I went through the process last episode, maybe. I feel like I've explained this recently. Yeah, and they get the blade wobbling at its natural frequency and keep it going. And so, it's not completely accurate the whole way along the blade again, but, towards the root, it is doing a pretty good job of representing the major loads. What it can't do is some of the, less frequent or less severe things. So you can't accurately represent gravitational loading because you don't change the direction in the same way that it does on a wind turbine. And then the other thing, which ties into, I think, another article that you have on the list for today, you can't accurately represent the load distribution and the way that causes twisting and torsion. That is not really adequately covered by the physical testing that is done on wind turbine blades. But, overall, they are in general doing a good job of representing it. And the evidence of that is that, they are pretty reliable over, decades of operation. This is the first time that and I don't know exactly what's happened, but it seems to me like this should be an issue that was caught in testing, and it hasn't been. And I think that this is the first time I've seen something so egregious like this in my career that should have been caught in testing, structural testing, but wasn't.
Lightning is an act of God, but lightning damage is not. Actually, it's very predictable and very preventable. Strike Tape is a lightning protection system upgrade for wind turbines made by WeatherGuard. It dramatically improves the effectiveness of the factory LPS so you can stop worrying about lightning damage. Visit weatherguardwind.com to learn more, read a case study, and schedule a call today.
I'll go back to Joel's point, which is the insurance companies are going to be looking for somebody else to hold responsible. And so will Siemens Gamesa.
The Siemens Gamesa is holding the smoking gun. And they've already put it out in a press release.
But there, as Rosemary has described to me many times, the blade has been quote unquote certified. It's been blessed, approved, whatever you want to call it, by the certification body, right? That says, you do these tests, we're good to go and use in the field. Something is missing here. Is it the testing, the required testing to get that approval? There's something missing in there. Is it that the testing wasn't performed correctly or something was missed or an oversight? Is it beyond that? I think that's where this ends up. Because it's happening so soon in the lifetime of these blades, you start looking back up the chain and saying, okay, there was a couple of gates that we had to pass through and checkpoints, and it passed, but how?
Well, I mean, okay, so I'm reading an article from 2021 here on Renews, and that says that UL is the certification company that did it. So UL has to give the type certification, right? You're a type 2S, you're a type whatever, blah, blah, blah. I think that we have to understand what circumstances the blade failed under before we can point back to the certification body as well.
Well, time out. Well, time out, because I do think if you're the certification body, you've taken on the responsibility, in my opinion, to be doing the advanced work, right? You need to be looking 4 or 5 years ahead so that wind turbine operators don't get into this problem, and OEMs get into this problem. You're supposed to be thinking ahead, designing these tests, bringing in industry experts like Rosemary to come sit around the table and go, hey, everybody, we need to improve this, that, and the other so that we can get rid of future problems. And this is the way you're going to, as an industry, move forward. That's what all the governing bodies, certification bodies are there for. The FAA, having worked with the FAA and been in that situation a lot of times, yeah, you can't ignore them, right?
I agree with you 100% there, but as it sits right now, if we're just looking at facts, we don't know the circumstances at what this blade failed under, and they might have been outside of certification, right? The certification may still stalled. So we can't point fingers there yet.
Yeah, and also, I mean, the fact that they've suspended a specific factory as as part of the evidence that we've got. I'm assuming that they're making this blade in more than one factory and that they're not suspended the other ones. It's possibly a huge factory stuff up. That they have accidentally rolled out a manufacturing process or got a wrong fabric or something that wasn't in the certification package.
I have heard this though. Like Rosemary's not wrong. I've heard that before, where you go back to the supplier of the turbine blade, and they can do their root cause analysis internally and go back and say, like, sorry, our supplier switched out a resin that we weren't aware of that passed certification here, but we didn't know, blah 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 blah. And that can happen. So that's possible that could happen. However, that is a breach of QA/QC processes, I'm sure.
Yeah, or someone could have mislabeled a weight of fabric, and they've been putting in a lighter fabric than they should have been in a certain place, or someone put a mold marking in the wrong place so that a ply is going up to the wrong place. Like all that sort of stuff happens from time to time, but I've never seen it happen, with this kind of effect and this kind of consistency and consequence.
By the press releases and stuff, I'm still in my mind saying this is a serial defect, this is a design issue. That's where I'm at still.
But Rosemary, your design engineer is saying it's not.
No, I'm not saying it's not. I'm saying it could be. It could be a factory thing. That would be the only way that you could say it wasn't a problem with the testing or the certification body. The other thing that I think is unlikely, but I guess you've got to raise, is that the certification body were misled because they do put a lot of trust in the information that they're given from the engineers and the manufacturers, and I don't know if you followed the Boeing, was it the Max or case well. So, there's some sort of parallels there. I mean, a lot of the time when I was following that case, I was like, all the things that were being slammed in the mainstream media, I'm like, yep, standard engineering. That's the sort of, how engineering works in any industry. And, you guys just don't know how anything you use is made or designed or manufactured. So, yes, there is a tight relationship between manufacturers and certification bodies. Sounds dodgy, but couldn't possibly be any other way, because, the certification bodies are never going to be more knowledgeable than the manufacturing companies and have, enough resources. They would need to be bigger than the manufacturing companies, to have more resources available to recreate from scratch without actually having access, so usually they're taking the manufacturer's word for it on how strong their materials are, and a few other things like that. But it's also, it gradually increases with time, the amount of trust. You might get less trust the first few times that they certify something, but after a while, when they see that, the things that you've told them, have proven to be true, then, they are taking your word for it a fair bit. But they're also taking your word for it that, when you say this design is, very similar to the previous one that you were already certified, they take your word for it that you're actually going to make that blade that you had them certify as well. And but I mean, you can't put the certification body in the factory to watch every single blade and every single worker. I just struggling to see how you could really have an arrangement without. Well, I mean, we saw in the Boeing case that they're also taking their word for it a lot. Aerospace is also more critical because people's lives are much more at stake than they are in wind. Yeah.
Well, it is. But is the temperature of the planet more important than one airliner? I think that most people would say yes, right? I mean, this is a huge setback. It's not. We're going to fix this next week, Rosemary. And I think the certification bodies are supposed to be, having seen it from the other side, the certification bodies are supposed to bring together the technical experts to put them from the different companies in a room to decide what the process should be on the certification side and verify everybody's doing the right thing. But also, and this is where aviation comes into play, they have a production certificate. There are FAA people in factories until they can stand up a quality organization that can show they're competent. The FAA sits there, and anything that happens that is abnormal, off drawing, any deviation, it gets oversight, all kinds of oversight. And so companies can go on for years with the FAA having direct oversight.
That's not a certification body. That's a federal agency.
Well, you're going to end up with federal laws against blades breaking off. Well, you're going to do it. You keep breaking blades like this, and this happened in the United States. If this happened in New York, offshore New York, there would be laws. You don't want to end up there. I think you don't want to end up there. And I think if you don't, as a certification group, and there's many of them, there's not just one, you better be thinking ahead.
Let's go back to the idea of just talking about certification bodies. So now we know there's a bunch of them, right? DNV, Bureau Veritas, UL, there's a stack of groups out there. And they're technically, for listeners as well, they're technically not like agencies of a government. They're privately held companies. They are just the ones that say that are looked at as the experts in the space that can certify to say, yes, this one will work. So they go to a third independent party. The OEMs do go to the third independent party, which is one of these certification bodies, and they come back and say it's good. So here's a thought for you now. We talked about last week too. Since 2010, it's been model after model after blade type after blade type just thrown at them. Do you think there's a bit of almost like complacency in like, oh, we got another review coming. Yeah, another month later, boom, you're good. Here's another one. Another month later, boom, you're good.
Is it a Big Short situation?
I don't know. I've noticed some real clogging of their systems at the moment. Like it takes a long time to get anything through one of those agencies at the moment, from what I've seen. So I feel like maybe they're continuing to, I see that they're taking longer to get through stuff at the moment. So if they've got a higher workload, then it doesn't seem to me like they're just rushing things through to keep business flowing.
No one says that they are, but if you design a system where that can happen, it will happen. The system's designed that way, right? This is the same thing about the mortgage bonds in 2007 and 8, right? You had the different rating agencies competing against one another for the AAA rating on a bond that was full of B's and C's. It's a big short.
But I think that one thing that keeps everyone honest along the way to a certain extent, like if I was a manager or an executive at Siemens Gamesa and I knew about this issue and was tempted to conceal that so that it could get through certification, is only, like a year later after that, I don't know when they certified this blade, but, like it's not very long before this is going to come back to bite you far worse than a delay in your certification would have, like it's hard to imagine. Unless, was there somebody, was the guy that was their VP of engineering, like did someone retire 6 months ago or something? Like that would be the only way that I could really see that he's like, I can't be bothered to deal with this, one more problem, just, like sign off, everything's fine, I'm retiring. Because otherwise, like if the guy's still there, then I feel like what did they gain from trying to hide something like this? I feel like maybe they didn't believe engineers, it was so serious, possibly, but I can't imagine it was blatant fraud, because there's just, a guarantee that you're going to get found out and it's going to be, come back and be pinned on you,
The way to obscure this is to push it back on the certification body and saying, we did the test to the standard. We are good. We did everything that was asked of us, which would be absolutely, I think every wind turbine blade manufacturer has been down this route. We did everything we were supposed to do, and there's a problem with the standard. Abso-freak-a-lutely. They have to go there.
I'll be so surprised if that's the outcome from this. This standard has been working for decades. This is not the conclusion from this is not that the standard is just grossly inadequate. The standards are getting refined over time, all the time, but
why?
There's no way the certification bodies, they've got good enough lawyers where they're not gonna sweat over this thing. They're not gonna have it. They're still gonna have a Christmas bonus.
Terrible reputational damage if it was pinned on them. But I would be really surprised to see the problem coming down to the certification body. And in any case, none of the manufacturers are really relying on certification as the proof that their turbine is good enough. The proof your turbine is good enough is that it does what it says, and that you don't get warranty claims, and that, the performance is good enough that your reputation means that people come and buy from you again. Like with Lightning, is the most obvious example of it. It's so easy to get Lightning certification, pass your, certification tests for Lightning, compared to having turbines with Lightning protection systems that actually perform as expected in the field. That's the harder part. People are somewhere in between the two, but nobody is just like, oh, we've got Lightning certification, that's job done. We can, we can stop working on, on this now.
Have you heard that, Joel?
If we can start talking Lightning, we'll be here until the freak cows come home, man.
I got a crisp American $20 bill.
I'll certify that. I'm
going to set it aside. If we start reading stories about the certification body and Siemens Gamesa,
I'll pay you one, because it ain't going to happen.
I'll give you an Australian $20.
I'll make up the envelope to Rosemary right about now and drop it in the mail by the time it gets there.
Yeah, here's your American $20.
I have been around this in the aviation too long. I just know how this always ends up. It's everybody points to the next stage down the path. I think it's inevitable.
I know some people at UL. I'll give them a call and see what the inside scoop is. See if they're getting phone calls yet.
All right, Joel will be the judge. Joel will be our spy. And we'll just send out an anonymous Slack saying Rosemary is right, and I'll put a stamp on it to Australia, and away it'll go, and she'll have a nice coffee on me. How about that?
Instead of 007, it's 005X for this one.
See, this is what this whole podcast is about, right? Putting three people on who don't necessarily agree, but are all trying to get to the right answer. I think it's one thing. Rosemary thinks it's another. It's totally fine. I think this is good to hash this out because this has to be happening at every water cooler at every OEM and operator in the world right now, right? At least I hope it is.
Especially if they have an order placed for SGRE5X turbines.
Our wind farm of the week is Appaloosa Run Wind Farm in Upton County, Texas, which is owned by NextEra Energy. It's near Midland and Odessa, Texas, kind of central Texas. They have 61 GE 2.8 127 wind turbines. Pretty cool site. The project was expected to cost around $260 million, and all that money went into the surrounding community. That's a good bit of coin. The farm is up and generating electricity just recently, and they have a virtual power purchase agreement with DuPont de Nemours. And Rosemary, that's a big U.S. company. But they're going to take off 135 megawatts from that farm. And that's part of DuPont's acting on climate goal of reducing absolute greenhouse gas emissions by 30%, including sourcing 60% of electricity from renewable energy by 2030 and achieving carbon neutrality by 2050. So a pretty cool project between NextEra and DuPont. So Appaloosa Run Wind Farm, you are our wind farm of the week. That's going to do it for this week's Uptime Wind Energy Podcast. Thanks for listening. Please give us a 5-star rating on your podcast platform and subscribe in the show notes below to Uptime Tech News, our weekly newsletter. And check out Rosemary's YouTube channel, Engineering with Rosie, and we'll see you here next week on the Uptime Wind Energy Podcast.